Welcome for physics lesson. We're going to discuss the applications of thin lenses, to be particular the converging lens, whereby the first application is what we call the simple microscope. The simple microscope. Remember to subscribe to this channel and to also share the link. This can also be called the magnifying glass. The magnifying glass. So we're going to draw some ray diagrams to show how a converging lens can be used as a simple microscope. For this to be achieved, let me first of all draw the principal axis of the lens. Then I also draw the lens which is converging for this case, a converging lens whose simple is as shown on this diagram. Now we have the optical center of the lens at that point. Then now I would like to identify what we call the principal focus of the lens. On one side we can have our F at this point, so that we have 2F, or rather the center of curvature at another point there. We can also have on this side F, then we also have at an equal distance twice F. So we write the principal focus F, and instead of center of curvature we can have 2F on that side and have the same on the other side, because a lens usually has two centers of curvature because it has been cut from two different planes, then they have been merged to F. Now we adjust the position of the object such that the object is found between the lens and its principal axis, principal focus, sorry. So when the position of the image of the object, object O, is adjusted such that it's found between the lens and its principal focus, an image will be formed. And I want now to get to ray diagrams and construct rays which will show us where the image will be formed. We can use any two important rays. One of the important rays is that a ray close and parallel to the principal axis can be drawn from the tip of the object. How this ray behaves after refraction is that it goes through F. So this ray will go through F of the lens after refraction. That is how the ray behaves. Then there is another ray that will go through the optical center of the lens, and such a ray passes undeviated. So if a ray passes through the optical center, it passes on undeviated. So these rays now are likely to converge on the same side as the object, and now we extend them now backwards. Yeah, we can have that. And on the other side, we repeat the same. We also extend backwards. So now the rays are intersecting somewhere here, and we will have an upright magnified image, which is virtue. So this is the image, virtue on the same side as the object, and it's upright and magnified. Therefore, if an observer is at this end, now he is going to see a magnified image. So that is how the lens can be used as a simple microscope. We also have what we call the compound microscope number 2. That is what I want us to discuss now. The compound microscope. Now the compound microscope has two lenses, both converging. So we use two lenses. The one close to the object, we call it objective lens. And the other one, which is closer to the eye, is called the eyepiece lens. So we are now going to draw two lenses. Let me start with the first one. They are arranged such that their principal axes are in line. So this is the uniform principal axis, and I'm going to draw the first lens, which we are calling the objective lens. So this is the objective lens. Let me elongate it for a little bit. The objective lens, which is converging. It has a principal focus also. So let's say we have a principal focus at this point. Then we have a C at this point, and on the other side we have the same. So this is going to be F. This is going to be C, or twice F. You're also going to have F and twice F at this point. Now that we are going to have two lenses, the first lens can be called, or we have said will be called the objective lens. So its F will be denoted F0 to mean the principal focus of the objective lens. The principal focus of the objective lens, that way. So the object is adjusted such that it's found between 2F and the F, 2F and the F for the objective lens. So this is the object. Now we can look at some ray diagrams which will lead us to the formation of the first image, which henceforth becomes object. So this ray will be close and parallel, and it will be refracted through F by the first lens. So through F, we're going to see the ray passing there. Then another ray which passes through the optical center now should proceed undeviated. Should now proceed undeviated. Therefore, a ray which is through the optical center passes undeviated. Yeah, this ray just progresses undeviated, which means the image will be real and upright, or real, and inverted and magnified. The image is magnified now and at this point. Now this we can call image 1. So image 1 now is adjusted in such a way that it becomes object for the second lens. So now we're going to have another lens placed close to this one. This other lens now will be called the eyepiece lens. The lens which is closer to the eye now, the eyepiece lens. Also converging. So this is now the eyepiece lens. But now the adjustment for the eyepiece lens is made such that the image, which now becomes object, lies between the lens and its principal focus. So F, but denoted FE. So the image is laid between the lens, the second lens now, and its principal focus. So now we can have this distance and an equal distance on the other side to have the same point here. So we can have now again F of the eyepiece at this point. Now we can again draw rays and see the formation of the second image. So I'm going to draw a ray close and parallel to the principal axis. A ray which is close and parallel to the principal axis. Such a ray will be refracted through the principal focus. So the ray will go through the principal focus. Yes, that is how the ray will behave. If we draw a ray through what we are calling the optical center of this second lens, such a ray is going to pass on undeviated. So from the image through the optical center, the ray passes undeviated. So this ray passes undeviated. After it passed undeviated, now we can see that the rays can only intersect now on the same side as the object. So we're going to draw now dotted rays beyond the image. Yeah, we will have the rays now intersecting somewhere. So after their intersection, now we can see an image which is upside down, virtual, so much magnified. Yeah, this is now the second image. So we will have image 2 at this point. So this second image now is what the observer at a point here will see. So the observer is at a point there, and he or she will observe an image magnified, upside down, virtual, two magnified image. Yet this is now a second image. So we have the object at this point. The object got refracted and magnified a little bit. Then now there is a further magnification of the same by the second lens. And that is how the second image is formed by the compound microscope.